During normal operation of the ammonia system, air and other non-condensable gases collect in the system. This air blankets the heat transfer surfaces in the condensers and inhibits the heat exchange from the refrigerant to the cooling water. As a result, the condensing temperature and the pressure increases, the system capacity is reduced, and the overall system efficiency suffers. The purpose of the ammonia purge system, AMP, is to remove these non-condensable gases and restore the operating efficiency of the system condensers. Purge points are provided at the most likely locations for air to separate from the condensed ammonia and collect. These points are at the lowest temperature, lowest velocity areas of the high-pressure condensers and receivers. For the evaporative condenser, the purge connections are located at the liquid ammonia outlet manifolds. For the shell and tube condensers, the purge connection is located at the top of the condenser shell at the opposite end of the gas inlet piping. The purge connection for the receivers is normally located at the top of the receiver. When the purge connection is opened, a mixture of air and ammonia vapor enters the purger. This mixture is referred to as foul gas. The purpose of the purger is to separate the ammonia vapor from the foul gas stream and to vent the air from the system. For filling, solenoid valve number 1 opens to allow liquid ammonia to flow through the liquid level control valve and into the purger evaporator chamber. As the rising liquid comes in contact with the sensing bulb of the level control sensor, the volatile fluid inside the bulb begins to condense. As the fluid condenses, the pressure to the level control valve operating diaphragm decreases, and the valve closes to stop the flow of liquid ammonia to the evaporator chamber. As the high-pressure liquid ammonia expands to ammonia suction header pressure, it begins to vaporize and cool the purger. The ammonia vapor accumulates in the top of the evaporator chamber and returns to the ammonia suction header. At the same time that the evaporator chamber is filling, ammonia liquid also flows through the 30 psid check valve and into the high-pressure separator chamber. As ammonia liquid expands across the check valve, a portion is vaporized. Ammonia vapor accumulates in the float chamber and is vented through the open number 2 vent solenoid valve. From the vent solenoid valve number 2, ammonia vapor is redirected into the incoming liquid ammonia stream where it is condensed. When the float chamber fills with liquid ammonia, the float ball rises and closes vent solenoid valve number 2. When the chamber pressure is equalized to within 30 psi of liquid line pressure, the check valve closes to stop ammonia flow to the air separator chamber. When the purger is cooled to about 25 degrees Fahrenheit, it is ready to receive foul gas and enters the automatic mode. A condenser purge point solenoid valve opens to allow foul gas to enter the purge header, and valve number 4 opens to admit foul gas to the purger. Liquid valve number 3 opens to recover condensed ammonia. Because the foul gas stream contains a mixture of ammonia vapor, air, and some condensed ammonia, the mixture first flows to a liquid drainer which separates any condensed ammonia and drains it to the evaporator chamber. The foul gas flows into the condensing coil where the ammonia vapor is condensed. The mixture then flows through a check valve and into the air separator chamber. The air travels along the top of the separator chamber and is collected in the float chamber. Condensed ammonia is recovered as it flows through the liquid metering solenoid valve number 3, strainer, metering valve, and then into the evaporator chamber. As the air accumulates in the float chamber, the liquid level begins to fall. When the liquid level falls to the float switch setting, the unit begins the purge cycle. During the purge cycle, the open condenser purge point solenoid valve closes and the purge gas solenoid valve number 5 opens. Air that has accumulated in the top of the float chamber is bled through the purge gas solenoid valve number 5, a vent orifice, and a 1 psid check valve. The vent orifice meters the airflow to the water column. Also, the orifice causes any liquid ammonia in the airstream to flash to a vapor that can be easily absorbed by the water. The 1 psid check valve prevents backflow of water into the purger. Water flush solenoid valve number 6 opens and mixes with the vented air. Flushing water is supplied from the plant water system. The water passes through a check valve and is then mixed with the purge gas flow from the vent orifice. Residual ammonia vapor is absorbed by the flush water. The ammonia-laden water is flushed to the drain through the overflow tube. As the air is purged, the level in the float chamber begins to rise. When the level rises to the float switch set point, the purge cycle is stopped and the unit resumes air collection as follows. Condenser purge point solenoid valve opens and purge gas solenoid valve number 5 closes. Water flush solenoid valve number 6 remains open for 30 seconds to fill the water bubbler with fresh water for the next purge cycle. After 30 seconds, the water flush solenoid valve closes.